I can email it to others if needed. Okay. Good morning, everybody. This is Anand. I've been in IT since 2003, working on various platforms in IT. Uh, so started working on Active Directory for several years. Worked on System Center Management Suite. There were a couple of years I was totally off the Windows technologies where I was working on products that used to get deployed on Solaris platforms and on Windows platforms as well. So we got a touch on a little bit on Linux and Postgres databases. Um, from past couple of years, 4.5 years, I've been involved a lot in cloud subjects, specifically AWS and Azure. So seeing that a lot of clients who have been interested to move off their infrastructure or the traditional infrastructure from um, what they have in their data center to maybe pick one of them. Could be AWS or Azure now. It depends on you as an architect. You go ahead and suggest something to them, right? Yeah, that's one part of it. There are other things that I also focus on, like IT security. So that comes as part of cloud security as well, right? So it's out of it is. Now, I usually ask this question to a lot of people. Is cloud computing really new? Are we really computing in the cloud or just in past 4 or 5 years, right? It's a food for thought, isn't it? The computing in the cloud has been there ever since the evolution of internet, right? Ever since it's been several decades. So if you think about your email solutions that you have been using ever since you created your email address, a Gmail or Outlook or Hotmail, we use Google Drive and SkyDrive. All of that is like storing data in the cloud. We do not have Exchange servers at our home to process your email. We do not have any directories at our home to authenticate your user accounts. It's all there somewhere sitting in the cloud and we never know where that account is actually located, right? But from about 2005, Amazon has done quite a lot of innovations and research in this sector and tried to put this to enterprise. Enterprises never used to use Gmail as a service. They had their own Exchange solutions. And cost cutting has been part and parcel of the enterprises, and that's where cloud computing technologies kick in and say that, okay, this is the solution where you can deploy your entire traditional data center or whatever. It could be infrastructure as a service or platform as a service to the cloud. Now, if we think about the various components of your traditional infrastructure, what do we have there in the traditional infrastructure? You have an ISP connection, you have routers, you have switches, you have firewalls, right? You got racks, everything that you see in that picture here, right? So that's how your traditional infrastructure will look like, you know. So there's going to be an ID card system which you're going to punch in. You'll go in there, then the temperature, the heating, air conditioning, all of that maintained. And there's a network operations center that is looking at that, continuously monitoring the systems for each of those thresholds like CPU or read writes or IOPS or network bandwidth. There's a lot of components that the network operating system network operations center looks at it using various tools like Nagios or SolarWinds or whatever. So that's how it has been in the traditional world, right? Now, one thing that I want to tell you that it is no different in the cloud. It is just a lift and shift from your traditional infrastructure to the cloud. It is just that you do not have to purchase those equipments. You don't have to purchase or even get a leased line from your ISP. You don't have to get a rack, maybe call Dell, go through the finance procurement process, which are very long and lengthy to get approvals. You don't have to call Hitachi to purchase SAN. You don't have to call Dell to purchase your servers, right? And you don't have to get vendors involved to set up the heating, ventilation, and air conditioning in the room. You don't have to call up the biometric vendors to set up authentication or multi-factor authentication systems to your data center, right? You don't have to do any of those things. That's one part of it. Another part is setting up a traditional data center takes a lot of time again, right? You need manpower and everything that's involved to set up kind of a data center, but that involves project management as well. In AWS, you don't need nothing at all. It's on demand. So when you actually provision, when you want to provision for a specific resource, it should be deployed right then and there, right? So total cost of ownership, which is called as TCO, has increased, right? The capex, which is called as a capital expenditure, which is also called as the initial investment, has gone down to zero from millions of dollars. The operational costs, which means the cost of heating, ventilation, air conditioning, the cost of human labor, the cost of electricity, everything that you need to pay month on month has gone down to whatever you pay as. So if you were paying like couple of thousands of dollars as operational expenditures, here it will be just called as pay as you go. If you use it, you pay for it. If you do not use it, you do not pay for it, right? So that's where the pay as you go solutions kick in, right? Okay. And this is really a big boon for the startup enterprises as well. So startup companies really will be looking for quick solutions and do not have enough funding to set up their own infrastructure. So that way cloud computing really helps. If you want to set up a server for about, let's say, 64 GB of RAM, couple of processors, and you are a graphic designer, you need that server, yeah, you can set that up in like 4 minutes. So I hope all of you have AWS accounts and have been playing around that for a while. But if you do not have one, I suggest that you create one for yourself. That way it will be really beneficial. In the interest of time, I would suggest that you spend some time setting up an AWS account rather than me helping you. But just in case there are problems setting up an account, do let me know. I can definitely help you sort it out. In the past couple of weeks, I've been in trainings in a couple of organizations here in Bangalore, and while I was setting up the AWS accounts with people, we had a lot of challenges. And the challenges were people were not able to create AWS account because their bank credit card company or the debit card bank did not allow AWS to deduct 2 rupees, because when you set up an AWS account, it will be deducting 2 rupees from your account. So certain banks do not allow that low amount to be deducted. That's one part of it. There's other factors as well, like limitations. Few people were not able to create beyond one virtual machine, which is just too less for practice purposes. We will at least need five machines, because I want to show auto scaling, I want to show load balancing to you. So we need at least 5 machines in that case. So we will figure that out because we got solutions for them as well. So when you encounter those situations, don't worry about it. You know how to get that sorted out, right? So go ahead and understand what is the definition of cloud computing. So cloud computing, now this is the definition that you see on the screen, is defined by an organization called as NIST. NIST stands for National Institute of Standards and Technology. It is an organization in the United States and quite an old company. It's not new. It's been there for a while, for about 180 years or something, right? So their job is to provide standards, or let's say measurement standards, and it's a non-regulatory agency, right? So you can consider that as an NGA or NGO or something we call here. So it's not governed by the government or any government in any country. So they define standards. So in that ways, they also define standards for cloud computing. What they say is that cloud computing is ubiquitous, it is convenient, and on-demand network access must be there. What does that mean? The first part, ubiquitous, it means that it must be available everywhere. It must be present. So when you provide or when you provision a resource in the cloud sitting in India, that means that it must be available from Africa, from Australia, from Japan, from South Korea, from the West, from the Middle East. Talk about anywhere. It must be available from anywhere, right? Regardless of geographical presence. It must be convenient for you to use, should not be difficult, should not give it complex codes and things. So, and that means it must be quick. It must be on demand. That means when you want to provision for resources, when you want to provision for resources, it must happen at that point in time. Um, just off topic, there was a big buzz about virtualization a few years ago in about 2009 and 2010, and that's where even certain companies could not afford the licenses of VMware ESX. So what did they used to do is to outsource that as well to something called as colo. Colo stands for co-location. I remember when I was working that we worked on a co-location in South Africa. So that data center in South Africa had servers from different clients, right? Servers from different clients were placed in one single geographical location. Few clients will put 10 servers, few will put 11, few will put to just 2, depends, right? So that's going in colo. So at that point in time, if you want to create a virtual machine in your server in that colo, you got to set up a request with the colo vendor. And the colo vendor will say, hey, okay, I'm going to take about 24 hours. And if it is really urgent, we can do it in 1 hour. But then that's going to be chargeable. 24 hours will be within the cost. Whatever, yeah? So that means that you still have to wait to prepare for the resources. If you want to provision a server, you have to wait. But NIST says that if you're going for cloud computing, it should not be that way. It must be on demand. That means it must be on your demand, right? It must be rapidly provisioned, quickly, and released as well. It's just not about provisioning. It's also about deprovisioning them. You want to get rid of it? Yeah, go ahead. Just right-click, delete, and that it should be done right then and there. And most important part is all of it must be done with minimal management effort and minimal service provider interaction, right? What it means is if you want to provision a server, if you want to provision a platform as a service called database or network or a VPC or data center in the cloud, then you should not be contacting Amazon to do that, or you should not be contacting Azure or Microsoft to create your servers, right? It should be having minimal service provider interaction and should not cause more of an effort to you. That means you should not be involved in coding and all that. With the help of GUI, it should make our life simpler, right? Although during the last couple of days in the training, I'll tell you how to do that with the code, specifically the JSON code, AWS CLI, and PowerShell. All three of them I'm going to show you. But that's what an IST says. You really don't have to know coding. and should make your life easier as far as cloud computing is concerned. Any questions so far? Okay, thank you. Moving on, that has been the evolution of cloud, right? Um, we started off with traditional data centers where we used to keep everything in the data center. We slowly moved out to virtualization, and in about 2009, 10, there was a big boom. VMware, a lot of organizations which were a Microsoft shop implemented Hyper-V, and then people wanted further cost cutting, and they said, okay, let's make private clouds. Private clouds is nothing but a cloud within your environment which you'll not be able to access from the internet unless you set up a VPN. So a private cloud is still on-demand service for the people. So if you want to set up a VM in your organization, you usually have to go through the virtualization team or the VMware team. But if you set up a private cloud, you don't have to do that. How is that done? That is done with the help of OpenStack tools or open source tools that are available for private cloud up and running. Even you can do that with that tool. Hybrid cloud is a combination of private and public. So hybrid cloud is done for two reasons. Number one, if you want to set up a part of your infrastructure in the public and a part of your infrastructure in the private, that is when you would like to go for a hybrid cloud. A use case or a real case scenario for this would be you would love to keep your front end or kind of a HTML site or a server that is hosting the HTML and CSS and everything in the cloud, and then you'll keep the backend, which is the database endpoint, you'll keep it in your public infrastructure, secured with firewalls. So that way, so you'll have connectivity between your private and public. The second use case is when you want to auto scale. That means that, let's say in your private data center, you got 10 to 15 servers behind a load balancer. And then the web traffic, there's a lot of web traffic that is hitting that load balancer. You can take an example of an e-commerce website. When an e-commerce website like Myntra.com or Flipkart or eBay, whatever, they set up, they say that, okay, from 11 to 12, we're going to have sale today. At that time, there will be a lot of traffic hitting the load balancer and the web servers. So the web servers will be at the peak, eating up 80% of CPU, good 60% of IOPS. Disk read writes will be very high. So the thresholds will be just up and running at, and that will be the reason for a user, for an end user to face slowness in accessing the website. So as an IT administrator or a sysops administrator, what you have to do is maybe set up another server, which you may have to spend more money. Organizations are now doing auto scaling in the cloud and saying that, all right, when there is a CPU load of 60%, let's move some of the services to the cloud. When there is disk read writes of about 80%, or maybe 20,000 gets and 20,000 puts happening at the same time, let me provision 5 servers in the cloud, so that way I can redirect the traffic to the cloud. So another interesting aspect is that when the sale is over, all of that traffic will come down. At that point, you do not want those servers in the cloud, right? So you will be deprovisioning those servers. So again, you got to write a rule there. When the threshold of CPU is less than 50%, kill one machine in the cloud. When the read writes of the disk are less than 5,000 gets and puts, then you kill 2 machines in the cloud. So that way you will be paying just for those 3 machines which have been provisioned for an hour in the cloud. right? So this thing is called as scaling in and scaling out. Scaling out is when you're provisioning new servers, and scaling in is when you're deprovisioning those servers when you no longer have that traffic demand. Public cloud is where your entire data is in the cloud, right? You put everything, like when you're using Google Drive, that is a public drive, public cloud. Email, all of your email solutions are in the public cloud. When you're provisioning servers in AWS or provisioning servers in Azure, it goes to public cloud, right? It has no link with your private infrastructure. Any questions?
Yeah, what is scale up and scale down, sir?
So I was just giving an example of the e-commerce website, right? So there's going to be a lot of traffic. Let's say there's a lot of traffic on the load balancer hitting. At that moment, the CPU utilization will go very high. So what you may want to do is spin up new servers, right? Because you want to make sure that the people or the end users who are facing the issues get the best performance out of your web servers. So you want to make sure that your system, that your network, or the processes that you have in your organization are able to handle the growing amount of workload, right? So there is a lot of workload during that peak season. So the servers will not be able to handle that much amount of load. At that point in time, you as a SysOps administrator or AWS admin might have to maybe create a few more servers to make sure that the load is distributed appropriately. But that, you may have to procure new servers again. We really don't want to do that because it's not a cost-effective solution. It's going to be expensive. So in the cloud, if you want to create new servers based on threshold, you can do that. If you want to delete the servers based on threshold, you can do that. So to answer your question, scalability is what I'm talking about. It is the ability of your network to scale up, which means provision new servers based on load, and then scale down, which is deprovisioning servers based on load again. Does that help you? Does that answer your question?
Yeah, okay, it's all right.
No, what does it mean it's all right? Do you understand this?
Yes, yes, sir, I understand. Scale
Okay.
up and scale down both.
Yeah, when you say it's all right, it means that you did not understand. Okay. So cloud models. We got certain cloud models here. They have defined it as SaaS, PaaS, and IaaS as well. So these are the top level models. There are others as well, like CaaS and XaaS. All of them are, the babies of these top level models. Let's talk about them one by one. So software as a service is, okay, which ways. Software as a service is called as um, usually when we use services like Gmail or Google Drive, where you do not have any control over patching of the servers or backing up information, that is what is called a software as a service, where you are no way concerned with how much bill are they paying, what is their electricity bill, um, how are they patching it, what is the patching routine, how many times do they back up, what is the retention policy. We never have to worry about it, right? You can think about solutions like Gmail or SkyDrive or Google Drive. There are certain incident management tools as well, like Freshdesk, right? Freshdesk is a tool, incident management tool that has been pulled up in the cloud. Even ServiceNow is there as a cloud, so you never have to worry about any kind of downtime. We can consider use Gmail. Did we ever worry about patching the system, right? We never have to worry about it. So all you will have is a user ID and a password to get in, and you can customize the interface. That's all. Yeah, of course, you can customize the interface, but there's nothing much you can do about that. That's it. right? Customize the interface, do little drag and drops and maybe add-ons. That's it. So you can modify the web interface. You can never modify the database. So you can never modify the number of columns and rows and joins and vectors that are there in the database, right? All you can do is modify the front end. That is software as a service. There are examples like Salesforce and Zoho. So in platform as a service, now platform as a service is a big advantage for startup companies. Let's say you want to set up and you have a great idea and you want to set up a software, right? So you start writing code in your laptop, but then now you need a database connectivity to it. Now you got a large customer database, and you want to put all of that database somewhere, which is highly redundant and also should be performing high. So that way you cannot keep the database in your laptop. You need some platform where you want to put all your information in. That's where platform as a service comes into picture and says, hey, you can use our database, right? The examples are SQL Server. So if you want to set up your own SQL Server, you have to purchase a license, right? And license is very expensive. Of course, there are open source databases as well, like Postgres, MySQL, MongoDB, MariaDB. There are lots of them that are open source. But again, if you want to set up a database in your premise, you have to set up a server first. In that server, you will be installing the database, license or no license, whatever. Again, you have to take care of your heating, ventilation, air conditioning, and all of that, which again, you're falling into the CAPEX and OPEX model. So it's going to be really expensive. Cloud gives you platform as a service where you don't have to worry about all of those services again. Just use the database. Infrastructure as a service is where you create the whole infrastructure. What does your infrastructure consist of? Remember the first screenshot where I was showing you the small picture of a data center? What does that consist of? It consists of routers, switches, firewalls, and everything that you think of, isn't it? So all of that is your infrastructure. That means you can set up your routers, your firewalls, your endpoints, load balancers, autoscalers, instances which are called as virtual machines. They can be created in the cloud. That's what infrastructure as a service is. I'm just using this picture as an analogy to make sure that we understand what your responsibilities are and what the vendor's responsibilities are. Let's look at pizza as a service. If you want to make a pizza at your home, it's going to be your responsibility in each of those factors. So it's going to be 100% your responsibility in setting up the dining table, in setting up the gas, in setting up the oven, setting up the pizza dough, toppings, cheese, everything is your responsibility. And that is an analogy to traditional data center, where everything will be your responsibility. But if you want to go shop for a few items, let's go ahead and shop for tomato sauce, shop for cheese because you cannot make it at home, shop for toppings because you can't make it at home, shop for pizza dough because it's going to be time consuming. So let's pick up certain things from the market. Let's come back and come back home and start cooking it, right? So electricity, gas, oven, fire, pizza, all of that is your responsibility in that case. So infrastructure as a service, take and bake is an analogy of infrastructure as a service where you say a part of it is my responsibility. So even if you are hosting your infrastructure or resources in the cloud and infrastructure as a service, certain part is your responsibility. Which part is we'll look at in the next slide, right? So most of it, about 50% is your responsibility, 50% is Amazon's responsibility. When using platform as a service like a database, it is close to pizza delivered. So you call up Pizza Hut or Domino's and say that, hey, I want a pizza. So there's no responsibility at all, except you got to set up the dining table and the soda at your home at least, yeah? You don't have to worry about the oven or fire or pizza dough or toppings or cheese or anything. So your responsibility has come down significantly when you're using platform as a service like or a database. What are the responsibilities? We'll look in the next slide. And when you're using software as a service, your responsibility is zero. You don't have to worry about anything, right? You're just going out and dining out and you order there, eat it, come back, right? We don't have to worry about the dining table when you go to Pizza Hut or electricity or toppings or cheese. They get everything ready for us and put it on the table. So that's what software as a service is. When you're setting up your Gmail account, all you got to do is um, just fill up the form, get that registration done, and that's it, isn't it? You don't have to worry about anything. So these are the services that I was talking about. When you are hosting on your premise, on the left side, let's look at the leftmost column. Everything is in your responsibility. You look at networking, storage, servers, everything top down, all the OSI layers, right? From the application, presentation, session, data link, physical Ethernet cables, the hubs, the routers, switches, layer 2 devices, layer 3 devices, applications, say Active Directory, Exchange, Outlook, everything is your responsibility in your premise. When you do the same thing in the cloud and infrastructure as a service, a certain thing that isn't your responsibility, which is virtualization. You don't have to care about what kind of virtualization Microsoft is using or what kind of virtualization platform Azure is using, right? So you don't have to worry about them. But we do have to worry about the patching of it, vulnerability. You got to put host intrusion detection systems like an antivirus in that. The data, what kind of data you're putting in, is that really secure, right? Opening up the port, you do not just uh, expose your network to the internet, right? So those things that you do not do, and it's your responsibility in that case. So you see that everything in blue is your responsibility. Everything in light peach green is vendor's responsibility. In this case, it's Microsoft. But the picture says Microsoft, but it's any vendor. It's a generic picture. Now, when you want to set up database in the cloud and going for platform as a service, you're responsible for the data that you're hosting in your tables and your columns. You're responsible for the applications that are connecting to the database. Amazon is not responsible for that. But Amazon is responsible for the virtualization, for the operating systems behind it, for the IOPS, for the performance factor, for the networking and rest of everything, right? Rest is software service where we don't have to worry about anything, right? Like your Gmail, like your CRM solutions, where we just log in with user ID and passwords, right? You can think about it as your payslip. Most of the companies outsource their finances, especially these pay slips, to other companies like ADP, right? So at the end of the month, you get a link and say, hey, this is your salary. Here's the link to get in. When you click on it, you just type in the user ID and password, and that's it. You get in there, right? You don't have to worry about what's going on in the servers behind the screens. Well, you very well know about hybrid, private, and public cloud. It was covered up in the second or third slide, but then just in the interest of people who joined late, private cloud is something which is within your infrastructure, within your premise, right? Well, you can say that, hey, I've got VMware within my organization. Is that private cloud? No, that is traditional computing. Private cloud, whenever I use the word cloud, it must fall in the definition of what NIST has given. So is your VMware accessible from anywhere? Is your VMware accessible from a mobile device? Can I provision your virtual machine from a mobile phone or a tablet? Can I do that while I am traveling? Right? Is it easy to use, or do I have to send a request to the VM team? Right? So all of those things are considered. So if I'm able to access your network infrastructure from anywhere in a mobile phone or anything without doing a VPN, right? Um, and nobody is involved except me in setting up that infrastructure, and I'm able to access that thing from any device, from anywhere at any point in time, provision any kind of resources that I want, then yes, your VMware environment is private cloud. So I've seen that organizations will integrate OpenStack with VMware, and with OpenStack they'll be able to create a nice front-end UI to integrate virtual machines. The computing is absorbed from VMware, whereas the front end and all of that stuff, the workflows, the orchestrator is driven and governed by the OpenStack. Hybrid environment is where a part of your infrastructure is in the cloud and another part of it is in your organization. I gave two use cases earlier where how that can be. A public cloud is where the entire infrastructure is in the cloud and none of it is in their premise. I'm gonna go and look at the demo in some time. Let's move forward with this. I want to talk about what are the key characteristics of cloud computing. It's gonna be a repeat, but cloud computing must have on-demand self-service, right? So the 5 points that you see are the key characteristics of cloud computing. Again, this is defined by NIST, National Institutes of Standards and Technology. So cloud computing must have on-demand self-service, it must have broad network access, it must be resource pooling, rapid elasticity, and measured service. Let's take a look at that one by one. When I say on-demand self-service, customer can select the resource needed, right? If you want to provision a server, yes you can. If you want to provision a server of 4 GB of RAM with 1 CPU for only 1 hour, you should be able to do that. You're not happy with 30 GB of hard disk that is attached to it, you want to add on to it, yes, you should be able to do that. Alright, you're patching the server now and you want to take a snapshot of that, yes. You want to deploy multiple machines out of that one machine, that one customized image, yes, you should be able to do that. So what I'm saying is that you should be able to do anything that you have been able to do so far in the traditional world. You should be able to access it from anywhere at any point in time, and the day you do not need the services, you should just be able to terminate. So no contracts or no rents. Rapid elasticity. So the point when the threshold is breached, you should be able to provision the servers, and the server is back to normal state, it should come back. So scale out is when you bring in new servers, scale in is when those servers are killed, and those servers are something that you don't need at this point, right? Measured service, the picture there is called as vernier calipers, isn't it? Everything should be measurable. The amount of resources that you're using in the cloud must be measurable. The CPU you have used at one point in time and the other point in time, you should be able to see graphs. So that ways you can be charged appropriately, right? So it should be measured. Pay as you go is the key word here. No rental, no contracts, right? Resource pooling. So this is another interesting aspect where we call it as multi-tenancy. You might have heard of Uber Pool or Ola Pool, where people from different locations can access the same card that you're using, right? So that's the same analogy here, where you may have a dedicated host somewhere sitting in the cloud, and you hosted a virtual machine. Now that virtual machine will be hosted in a particular rack or in a particular server in the Amazon's data center, and you are in one geographical location, let's say India, and there could be another guy who's hosting up another virtual machine, and it may land up in the same physical rack, right? So you're not getting a dedicated host in the cloud, although AWS gives you an option for dedicated host. All of these machines are virtual machines that you're provisioning in the cloud. And these virtual machines may land up somewhere in a dedicated host with lots of other customers' virtual machines as well. But if you want a dedicated host, yeah, AWS does give it to you. So scaling up, so you should be able to provision servers with the help of multi-tenancy. So multi-tenancy is a low-cost solution, but if you want a dedicated host, it's going to be expensive. Broad network access, yeah, like I was always saying, you should be able to access it from anywhere at any point in time. Internet is the backbone, should be able to access it from any web-enabled device. This is a picture of the number of data centers that we got. There are two in west coast of the US, there are two in the east coast of the US, there is one in Sao Paulo in Brazil, there's one in Mumbai, there's a couple of them in the Southeast Asia and two of them in Australia, a few in Japan as well. So they got large number of data centers spread geographically. Not just data centers, they're called as regions. Data centers are called as regions. Not just regions, but they also have something called as availability zones. I'll tell you about availability zones and content delivery networks when we talk about VPC. We'll talk about them. This is a Gartner. Gartner is an organization that does just lots of research, right? They just do research. Let's say, which is the best company in terms of employee satisfaction? Which is the best car in the 4-liter car segment, right? So they just do any survey. So they also did a survey in cloud computing and said that, okay, who is a niche player? Who is a visionary? Who is a leader in the cloud computing? So they made 4 quadrants out of it and created this particular graph. On the left side you see 2014 chart, and on the right side is the 2016 chart, right? So in the 2016 one, you see that AWS is on the top. 2014 one, AWS is still on the top, isn't it? But Microsoft has made their way a little bit and trying to reach AWS. And Microsoft has done a lot of innovations as far as the front end is concerned, the front UI is concerned, giving new services is concerned. So you see that the gap has considerably reduced between AWS and Microsoft in 2016. Yes, there are other vendors as well. There's Google who's talking about G Compute. There's IBM is calling about SoftLayer. There's Computer Associates, CSC, Rackspace, Distillation, VMware, HP. Everybody is creating their cloud solutions. Oh yeah, Cisco as well, Cisco Cloud. But then AWS is still the leader. So when you say leader, there are different parameters based on which they get this positioning. So any questions for me? You can either post your question in the chat or you can unmute yourself and ask it to the audience here. A couple of questions asked in the chat. It says, can we get this session recorded? Yes, this session is getting recorded. I'll upload it to some of the internet sites and share it with everybody. Any other questions? I will move on to demo if you do not have any questions. Okay. There's a question here from Sarup. It says, what are the typical use cases of private cloud customer in terms of security? Your question isn't right, or maybe I'm not able to comprehend properly. Can you please open up the mic and maybe explain that? Okay, a problem with my mic. So I'll go with my understanding, right? Okay, I'll go with my understanding. You're saying that what are the typical use cases of private cloud customers in terms of security? Now, what are the scenarios in which somebody would like to go for private cloud? I will go with private cloud when I really think that I do not want to put my data in public cloud. That means that I still do not have confidence in public cloud. When my data, when I say data, it is intellectual property, it is consumers information, right? Consumers information which is classified as PII, personally identifiable information. When that goes in the cloud, and that consists of social security number, first name, last name, date of birth, PAN card, Aadhaar card, and uh, all of this will go in the cloud. When somebody, when we put it in the cloud, it's really a big concern. And when large companies, especially financial companies, put their data in the cloud, I will be in a real panic situation. You're putting it in the cloud and then you're saying that your data is secure. But then it is actually secure. You know why? Because large organizations like this, AWS and Azure, they get certified on various platforms. They get certified from HIPAA, which is health insurance certification. They get certified from FedRAMP, which is Federal Risk Assessment Management Program. What it means is that even government sectors in the federal programs in the United States are now putting in the cloud. That's a big thing. If the government is putting the data in the cloud, that's really a big thing, because they are the ones who have the topmost private confidential intellectual properties, which should not be shared with any other organization. Now, when they are putting it in the cloud, that means the government has a lot of confidence in Amazon or in AWS. When you talk about your private information getting into cloud, which is banking companies, financial companies, health and insurance companies, they are going for the cloud for sure, because you have control over the security in the cloud. You can say what ports to open and what not to open. You can put network intrusion detection systems and network prevention systems to handle the DOS and the DDoS attacks that's going on. Apart from that, Amazon also has a layer of security, which they have set up. They have set up physical securities. They have set up physical securities like the security guards and gates, which are protected by multi-factor authentications. And you got multi-factor authentication is something that I'll explain moving on, right? So that's how it is. Does that answer your question, Swaroop? Okay, great. There are a few more questions here. Let's go with them one by one. Which good service does, what is it? Which good service does AWS come? Which cloud service? Which cloud service does AWS come under? Okay, the AWS comes under infrastructure as a service because it will let you create all of those services. It will let you create servers, firewalls, data centers. AWS also comes under platform as a service because it will let you create databases, RDS and no RDS. AWS also comes under software as a service because it will let you create directories and emails. So it's everything. It's a one-stop solution. Another question, how the migration will happen, physical to cloud. Is there any post and pre-step required? It's a very good question. The question is, can we migrate your existing virtual environment like VMware to the to the cloud, to the AWS? Is there any preparation required? Yes, there is a preparation required. There are certain tools that you have to install in your premise on the virtual machine. So you install AWS CLI, run certain commands, and then you import it into your cloud. Yes, there is a preparation required. What are the other options for security other than identity and access management? Sushant Kumar has a question. What are the other options for security other than identity and access management? Amazon provides identity and access management where you can create role-based access controls. Security is a general word that we are using. Security is for servers. Security is for your VPC. Security is for the content in your instance. That is governed by two methods. One is NACLs, which is network access control lists. Another part is security groups, which will let you pass the data in and out by modifying the inbound and outbound ports. The other part of identity and access management is who should access your AWS account. If I have to explain that more, in an organization there will be different teams. One is a storage team, Active Directory team, and there is an Exchange team. Everybody is there, and the VMware team wants to give permissions to everybody. They will not give root access to everybody, right? They will be giving just the amount of permissions they need to access. Say for example, they want to access just the S3 service, or somebody wants to access just the Glacier resource in Amazon. And I, as a finance guy, I want to access everything, but I want read only, right? So that ways you can control things with identity and access management. But when you say security, yes, you can do that. Security can be controlled. Data in and out can be controlled with NACLs and um, security groups. And any other questions? Does that answer your question, Sushant? Great. Any other questions, guys? All right, so I'm just logging into my AWS account now. I've set up a MFA with an RSA token, so I have to punch in the number here, which I'm looking at the device. Should sign me in. All right. So the services that we're going to cover as part of AWS Administration course, and I'm saying administration, I'm not saying sysops or architecture course, I'm not saying that, because we're going to cover both of them, right? I'm going to tell you all of that. Mostly it's going to be on the admin side. So the ones we are going to cover is EC2, Elastic Beanstalk, S3, EFS, Glaciers, RDS, DynamoDB, VPC, CloudFront, Route 53, which is my favorite topic there, the DNS, right? So Route 53 is you're going to talk about CloudWatch. The last day, we will do CloudFormation. You will find this very interesting. CloudFormation. We'll do identity and access management. Directory service will be there. SNS, which is simple notification services, which we'll talk about. Then workdocs, workmail, workspaces, all of that will be done as part of it. So you got a training agenda as well with you, I believe. So we'll get that done as part of it. Now there are certain things within EC2 which is also important. Number one is a load balancer. So we'll create new servers. We'll create two servers and make that as a website and make sure that we balance the load between the two servers. So I'll show you NS lookup tools to see how do we balance the load, and that part is here actually. Load balance, and we also do auto scaling. And I was talking about elasticity, right? Auto scaling, we also do that. There are two parts of scaling again. One is vertical scaling, another part is horizontal scaling. The vertical scaling is when you add new resources to the existing instance, right? So a virtual machine has 4 GB of RAM and you want to make it 6 GB or make it 2 processors or make it 8 GB or adding resources to that. That is called as vertical scaling. Horizontal scaling is, let's say you got a server with 4 GB of RAM and you get another server with another 4 GB of RAM and you keep on adding to that, is horizontal scaling, right? So we'll do both of those in the EC2 section, right? I'm going to share the best practices and the documentation that I got as far as the preparation for the exam is concerned. That's how it is. Any questions, guys? I'm done as well. So yeah, on the flies you cannot do, Kamresh. So there was a question here, can we add resources like CPU, memory on the fly? On the fly you cannot do, you have to shut it down and then add it and then start the machine again. You want me to show something like demo or something? Let me know. No, without terminating. Okay, we don't have to terminate the instance, Kamresh. We can just stop it, add the resource, and start it. Terminating is different. Terminating an instance is deleting the machine when you do not need it at all. Okay, Sriram is asking for demos. I mean, let me just pick up an EC2 here. In fact, EC2 is good. So when we go for, I'm just trying to launch an instance here. All right. So when you want to create an instance, it's going to give you a menu. It just gives you a menu of all the images that Amazon is providing. Now every image has an image ID. This image ID is very unique. You will need this when you are scripting on the cloud formation, or when you're doing Python or PowerShell. You will need these image IDs, right? So for Amazon Linux image, this is the image ID. For Red Hat, that is the image ID. These image IDs are different. Now make sure that you are selecting free tier account only. Some of these virtual machines or some of these images are not in free tier, right? So if I select this, I'll be charged any which ways, because my account is 4.5 years old and I keep getting bills month on month. So that's my billing. Yeah, so this is my bill so far. So I get last month I paid like $17. Next month, see, this is my last month's bill. This is current bill till date. The next month will be 30. So I don't have a free account. Can you show us how to spin up an EC2 using CloudFormation? Vicky, that is an advanced subject. That is an advanced subject. Maybe you will be able to understand that, but others will be lost. I can show that to you one-on-one, because there are a lot of prerequisites that I need to cover before I even touch upon CloudFormation, which I will not pick up. So that is an advanced subject. I'll leave it for the advanced classes. So if you want to provision instance here, you need to pick that up, say select, right, Vicky? So if I do that, right, a lot of people will be lost, and the demo will not be great. So I really want to make sure that everybody understands what I'm doing here, because I don't know everybody's technical background. There are about I don't know, good double-digit numbers here. I don't know everybody's technical background. Somebody may be a fresher, somebody might be very experienced, and if I pick up an advanced topic for demo, there's a high scope to somebody to be lost in this space. So I've selected an image here, and what you see now is the resources, what kind of resources that you want to choose. So somebody who's a graphic designer, right, or somebody who wants to create a code that needs high amount of resources, they will not choose T2 Micro. In this filter, you can select any optimized machine. I want a machine with high graphics, with a Radeon card or something. So this one will have 4 CPUs and 61 gigs of memory. That's a lot, right? You may have to pay as well, pay for those machines as much as I mean, it's directly proportional. You set up a micro instance. So for now, I'll just go and pick up a general purpose machine, which is T2 micro and must be eligible for free tire. Okay. Next. Okay. Sorry about that. So once I've selected my instance, I hit next. This is where you can select the networking aspects of it. The first part is how many instances do you want to spin up. The second part is more for bidding purposes. So usually the cost of running is about half a dollar, maybe a couple of cents. In this case, it is 0.05, 4.5 cents an hour, which is very cheap. But then if you want to bid for it and say that, okay, I cannot pay that much, but let's say I want to set up an instance with a cheaper cost, I can set that up here and say that, okay, this is what I want to bid for. Okay. There are few more questions coming up in the chat. I'll address them, all of them, once I'm done with the demo. Now in the drop down you see the data centers. Now this is part of the VPC part. I've set up my own customized VPCs here. So in which VPC do you want to set that up in? In which subnet do you want to put your server in? Do you want to give it a public IP? Do you want an IAM role assigned to it? When you shut down the server, do you want it to stop or terminate? Enable accidental protection. So when you right click on an instance and then say terminate, it should give you an error. So anybody should not be able to even accidentally delete it, right? So if you check it, that will not work. So again, you may have to modify that setting later on once the server is provisioned. Enable CloudWatch monitoring. So monitoring is where you want to see the CPU, what's going on in the machine, the network IO ops, and the disk throughputs is something that you want to see is done with cloud monitoring. You will get cloud monitoring even if you uncheck it, but if you check it, you will get cloud monitoring at 1 minute interval. With CloudWatch detailed monitoring, you will get at 5 minute interval. Yeah. And do you want a shared instance, which is multi-tenancy, or you want a dedicated host is what it is saying, right? Let's keep it shared. Dedicated host is where the hosts, the virtual machines that where you are hosting on are all hosted on one particular host and no other consumer is using it. There's no other client or no other customer will be using your dedicated host. But when you use a shared host, there can be other customers as well who are present in that physical rack. You can add one more network card to it. This is a similar configuration as VMware. Yeah. So yeah, I want to continue. Next. Right. How much of hard disk space you want to give to this? So at this time it is 80 GB, but in the free tier account you can go up to 30 GB. You can also add new volumes to it, right? Like a C drive and a D drive, etc. Tagging is very important for the billing perspective. You can pull up reports based on tags, and also it will help you set up, give you a friendly name to that. Yeah, so I can set up a key as like this: business unit is application team. I can say put up another tag and say time 4 months. Right? This will help me for a couple of reasons. Number one, for billing purposes. Number two, for identification. Right? Number three, I give it a friendly name and I say that, okay, it's a web server. That way I'll be able to identify that it's a web server. Security groups are the most important part. How do you want to access and where do you want to access it from? Since I've selected a Linux server, it says that, okay, you got to open 22. But then if you wanted it to be a web server as well, you will open port number HTTP as well, which is for HTTP traffic. The last block, the last column that you see here says from where. So when you're writing a rule, on the firewall, it will have the following things: source, destination, port number, protocol, status, right? So source is an IP, destination is also an IP. Source is an IP from where the traffic is generated. Destination is the receiver of that traffic. Port is which port do you want to open. If it is HTTP traffic, you open port number 80. RDP traffic, you open 3389, right? Protocol is whether you want TCP or UDP. Status, whether you want to allow or deny that traffic, right? That's exactly what we will be doing here. It's just that you're not putting in the source part of it. Sorry, the destination part of it, because the destination is itself. Destination is this machine itself, right? When I'm putting 0.0.0.0, it means the entire internet, the whole internet. This machine will be accessible from everywhere. But if I set up my IP, it will be accessible only from my laptop only. So this is my public IP, right? Or I can set up customer and say that I maybe ask customer's public IP. This web server that you're provisioning is for a customer, and you want only customer to access it. So you will ask, hey, what's your public IP? Customer will give you a public and you put it here. That's where you are making it more secure, right? So for now, I'll say anywhere, review and launch. It's gonna review that. This is not an error message, it's just a warning. It's a warning because I'm saying that I've opened up port number 80 to the internet, which is not a good security practice. So I'm launching a Linux image, and this is a T2 micro instance. I'll be getting 1 CPU, 1 GB RAM. The ports that are opening are this, right? So that's it. This is important part. In Azure, when you're provisioning a machine, you will get a screen where you can type in the user ID and password and confirm password. Here you don't get it. Here you do not get it at all. You need to use a key pair. Key pair is cryptography. So it's a public key asymmetric cryptography that is happening, right? To decrypt the password. It is not a straight off password. So I'll give a password, let's say web server demo or something, and download the key pair. All right. So one thing to keep in mind is that once you have downloaded the key pair, you will never be able to download it again. Yeah. So make sure that you download it and keep it in a safe place. Launch instance. That's it. We'll go back. The machine is not ready yet. It's just doing its job. It's pending. This should complete. The status must be 2x2 checks complete, and that's it. It should be done. So, yeah. I'll go back and address some of the questions in the chat. Can we add resources to running instances? Running instances, no. You have to stop the machine, add the resource, and start it. Okay, I think it's been answered. That means you must have to stop a running instance and do the updates. Like, yes, that's right. When I go for dedicated host, who's responsible for patching and all? For dedicated host, it's your responsibility. It's just like a VM in a VM environment. Okay. Is there a way to recover the key pair if it's lost at all? No. That's what I was saying. If you lose the key pair, there's nothing that you can do it. Amazon cannot do anything about it. You're losing a password. You're losing a password. What can Amazon do about it? Yeah. But the best practice. What is the best practice? The best practice is once you are in, once you have SSH to your Linux machine or Windows you logged into RDP to a Windows instance. What do? What you can do is reset the admin password, right? There will be a default admin password that all the organizations use, right? In your company, there will be a standard password. You reset it to that, and then also, I mean, not everybody will know that password, but then you reset the password, and usually you keep it in a password repository or something. Also create a user account and make him part of the administrators group. So that way you will have a backdoor entry. Okay. Any questions? Sai, you're saying, can you explain with an example? Which example are you looking for? Yeah, deployment is done within minutes. Yeah, it's pretty quick. One of the key characteristics of cloud computing, right? It should be done very quickly. So this one is done. So I'll just copy this public IP, and since it is a Windows machine, I have to put it to it, right? I have to. Oops, sorry. And paste it, right? It is not a straight off login here, especially in Windows. You have to generate a PPK file from the PEM file. I've downloaded the PEM file, it's right here, but I have to generate a PPK file. So let me generate a PPK file right now, and this is just for Linux machine, not for Windows machine. So I say SSH auth browse. Now I'm going to browse it to my, actually I've got to go for the putty gen. Where's my putty gen? Alright, that's my putty gen. I load my PEM file that I downloaded, just the web server. Okay, and then I will save the private key and save it as web server.pk. Save it. Alright, authentication, browse. That's it. Open. Can you see my screen, guys? Everybody, is the screen shared yet?
Yes, sir. It's visible.
Okay. Thank you. There's some problem here. Connection timed out. Let's see what the problem is. View inbound rules. The first thing what I'm going to do is telnet to this and see if I'm able to connect using telnet. Telnets and paste, say 22. Okay. So there's some troubleshooting here. Now this will be interesting for you. I'm not able to telnet. So that means it's not a problem with my PEM file. It's a problem with my networking aspect. But I have port number 22 open. All right. Let's go and troubleshoot. Now this machine is hosted in a VPC called as this F0E. I'm gonna navigate to my VPC section and see which one is my F0E. Ping, Swaroop, ping will not work because I do not have ICMP port open. I only have port number 20 and 80 open, so ping will not work. Okay, 0, where's that? Which was that? F0E. So that is my data center in which it is in. Okay, so I will check the health of this guy first. So okay, F0FE subnets, and I also want to check in which subnet it is in. It is in F90. Subnet is F90. Okay, subnet is F90. That's the one. It's got a public IPS. That is night. So that's the problem. Where is the internet gateway? B9. Okay, there's no internet gateway. Created. No problem. There's a problem with the routes, guys. Routing is not right. I'll fix that in a minute. And it does not have an internet gateway assigned as well. So I'll attach it to my VPC, which is my data center. Done. Last one more step and that should be done. Yeah. Okay, add another route. Oh, I think I attached it to the VPC. Oh, this IGW is already attached to F0E, which is mine. It is taking some time. Okay. Any other questions so far, guys? While I am fixing this, you can think about it and post it in the chat. It's already attached. F0E. No questions? Okay, that seems to have been attached. So I'll go back to my route table and add some entries here. Okay, just 0 dot because I want it to be accessible from the internet. /0. That is my data center. Save it. Okay. Okay, that's done. So I'll do telnet one more time. That's it. Telnet is done, right? SSH is open. Now I will do putty one more time. I'm in, guys. EC2 FL user. So that's a VM you saw that we got created in one of the data centers. Those data centers had some routing problem. We fixed the routing problem, and that's sorted out. So that's the end of the demo so far. Like I said, when we're doing the actual training, we'll be going through the topics that I discussed earlier, all of these that I said. And if you'd like to customize the session, I hope everybody has a training agenda. If somebody doesn't have it, please do let me know. I'll put that in the group and we'll take it off from there. That's my email address. Right, that's my email address. You can mail me if you want, or you can either put it up in the chat and we can take it off from there. So if you don't have any questions, we'll wrap it up from now. Yeah, I'll share that agenda in the group. Thank you very much, guys. Have a good one. Unless you have any questions, I'll be here. For those who don't have any questions, nothing to talk about, we can continue to be in touch in the group. For those who have questions, can stay back. I'm here anyway. So thank you, Kumaresh. Thank you.
Okay, thank you, sir.
Thank you, guys. Bye-bye.
Bye.
Thanks, Sriram.